Okay, we're back. We're going to take a look at a few more. Okay, arc lengths. All right. Now, what arc length is it trying to find? Remember, arc length is a fractional part of the circumference. Okay, fractional part of circumference, which means it is, okay, given by this formula, an arc measure, let's just say some arc measure AB over 360 times 2 pi r. Okay, let's label what we got. Angle BCD, I think that's been mislabeled. I think that should have been angle BAC. I'm going to presume that's 60, okay? And AB is 5. And what am I looking for? Arc ADC. That's kind of mislabeled too. So I'm going to say I'm looking for arc BC. Okay? So just make those corrections. So what am I looking for? I'm looking for 60 over 360. 60 over 360 times what? 2 pi times the radius, which is 5. So that's 1/6 of 10 pi. And I'll just simplify that fraction to 5 pi over 3. Okay, let's look at this next one. Okay. This one, DAC, is 90, and BC arc is 30, which means that CD arc is 90, and this angle here is 30. And what am I looking for? And the radius is 12, and I'm looking for arc BD. BD is the minor arc here, which is the arc swept out by 120 degrees angle, so it's 120 over 360 times 2 pi r, which is 24 pi, because r is 12, so that's 1/3 of 24 pi, which is 8 pi. Okay, and see down here, this is the sector. Okay, and the sector area is a fractional part of the area of the circle, which is equal to the arc angle over 360 times pi r squared. Okay, BAC here is 60. Sorry about that. BAC here is 60. So we're looking at 1/6 of, and the AC, the radius is 8. 1/6 of 64 pi, that's pi r squared, okay? So that's 32 pi over 3, and we'll leave it at that. It's best you leave them in these fraction forms. I'm most impressed when you do that, okay? You want the shaded area, okay? Now what they give us here, don't fall for this. This is 135, okay? I don't want that angle. I want this whole angle here, okay? Which is 360 minus, okay, 135, okay? 360 minus 135, okay? So that's what? That's 5, okay? That's that's 225 degree arc. So my arc that I'm concerned about is 225 over 360 times pi r squared, which is 100 pi. That's because r is 10. Okay, so make sure you see that this arc is the 225. Now, I should know that 225 over 360 will simplify as a fraction, okay? I'm thinking 135 kind of splits up into 3 equal 45s, okay? So 135 is 3/8, so that makes 225 5/8 of 100 pi. And I could just leave that as 500 pi over 8. 500 pi over 8. Maybe I'd simplify that to what? 100 and divide by 4. 125 pi over 2. Okay, so let's simplify font. Let's do 1 and 2 more for this. Okay, these are a little bit more involved actually. So let's do 1. We're looking for this is the segment of a circle. That's this shaded region, and that shaded region is the sector minus the triangle. Okay, and we just did the sector. So the sector is what we just did in the previous two problems. Okay, fractional part of the area of the circle. The 90 degree. So basically we're finding all this whole area here. Okay, and then we're going to subtract from that the okay. We're going to subtract from that the area of the triangle. So, you know, that sector is 1/4 of pi r squared. AB is the radius, so it's 12 squared, 144 pi, minus the area of the triangle. What's a right triangle, right? It's a right triangle. This right triangle, composed of two radii of 12 and 12. Okay, so in a right triangle is the simplest thing in the world because it's simply half of a rectangle, right? So it's half the product of 12 and 12. So what's that give us? 36 pi minus half of 12 times 12 is half of 144 or 72. So that's it, 36 pi minus 72. I'm going to terminate this one here and continue with another one.